Welcome, everyone, and good afternoon. It's time to begin our event. I'm Joe Helble. I'm the Dean of the Thayer School of Engineering, and it's my distinct pleasure to welcome you to the first event of the first ever comprehensive Thayer Alumni Weekend. So, alumni, welcome back. We're pleased to have you here. Our kickoff event, as you know from your program, is a discussion of energy, a subject that's very much on everyone's minds, very much in the news these days, very much a focus of much of the research and teaching here at the Thayer School of Engineering. Before we turn to our panelists, I'd like to take a moment to introduce our distinguished guest and initial speaker, and that is the president of Dartmouth College, Phil Hanlon. Philip Hanlon, class of 77, became the 18th president of Dartmouth on June 10th, 2013. He is the 10th Dartmouth alumnus to hold the office of president and the first one to do so in nearly 30 years. President Hanlon was formerly a professor of mathematics at the University of Michigan and earned his Bachelor of Arts degree from Dartmouth, where he graduated Phi Beta Kappa. He is an accomplished academic and administrative leader, and most recently served as the Provost and Chief Academic Officer at the University of Michigan, where he had been a member of the faculty since 1986. Upon graduation from Dartmouth, after earning his AB in math, President Hanlon went to Caltech, where he earned a PhD in mathematics, and then returned east to MIT, where he was a lecturer in math before he made the unusual and nearly unprecedented step of being hired as a tenured professor of mathematics at the University of Michigan. It's been a pleasure to have him here with us for the past nearly 2 years, and so I ask you to please join me in welcoming him to kick off our event. Phil?
Thank you, Joe, and good afternoon, everyone. I want to welcome back particularly Thayer alumni and friends back here for Alumni Weekend. We're always so pleased to see you back on campus. At a lot of reunions, the key activities are socializing and reminiscing about old times, perhaps over a few drinks. Evidently not so at Thayer. No such fooling around. Instead, your reunion should take on problems no less formidable than the world's global energy demand. So that's impressive. Impressive work for a reunion. But in so many ways, I think that this appetite for taking on the formidable challenges of the world, it really characterizes Thayer. It characterizes Thayer students, your faculty, and alumni. And it's so essential to Dartmouth's ambitions for the future. On September 4th, 1882, the Pearl Street Station in New York City came to life, the world's first electric power plant. It served exactly 85 customers, lighting about 400 lamps, including notably in the newsroom of the New York Times. So someone had a nose for PR even back then. But with the throwing of that switch on September 4th, a new age dawned of technological and industrial wonder. That first day, for those 85 customers, Edison's plant directed about 600 kilowatts. And today, 7 billion citizens of the world demand more than 20 trillion kilowatts. By 2050, with a population exceeding 9 billion, demand is expected to double from today. And by that point, it's thought that we could face a gap between supply and demand that's almost equal to the world's entire energy output just a decade ago. And so as we ponder this question, as we ponder the realities of climate change, we ask at what cost will we provide that energy? How do we strike a balance between supply versus demand versus stewardship of the planet? And to state the obvious, these are really profound and complex questions. And today we're privileged to have a panel of such accomplished Thayer alums who will talk with us about the energy challenges of the world and some of these formidable challenges. Great universities like Dartmouth have the capability of bringing together a diversity of thought and perspectives, including the most important thought leaders in a given field, just as you're witnessing today. Today's panel demonstrates why Thayer will always be such a source of great pride for Dartmouth and vital importance to our institution's future. And I say with great confidence that a university without a world-class engineering school is only half a university. So that's why I am so bullish on significantly expanding Thayer, and why I'm asking all of you as alums to join me in making that happen. I think your engagement's going to be crucial to this amazing opportunity for Dartmouth. So we couldn't be happier than to welcome you back. I hope your discussions will be productive, and I truly hope that at least by the end of the day you'll get a little of that time for reminiscing. So enjoy the panel, and thank you very much.
Thanks very much, President Hanlon. So, this issue of energy is a particularly interesting one for the Thayer School to be tackling at this particular moment in time. In 2007, we gathered as a faculty here and began a strategic planning process to identify specific areas for the Thayer School of Engineering to invest in, specific areas for focused programmatic growth, specific areas for faculty growth. And in doing so, as a faculty, consistent with the long-standing interdisciplinary and collaborative traditions of this school, we made a decision not to focus on engineering disciplinary areas like mechanical engineering or electrical or chemical, but rather focus on the big interdisciplinary challenges that are facing the world. And out of that comprehensive and engaging faculty discussion came the decision to focus as a faculty on energy as one of the key strategic, technological, and geopolitical challenges of our time, with the Thayer School, of course, focusing on developing technology-based solutions to this wide-ranging problem. Now, it's easy to see how one might choose energy as an area of faculty focus and faculty expansion when oil's trading at more than $100 a barrel. It's easy to forget how important it is in times like today, where it's trading between $50 and $60 a barrel, or when the price of natural gas is only scarcely 25% of the price it was 5 to 6 years ago. But of course, the challenge associated with energy is so much more than the price of fossil fuels. It is about domestic versus international supply. It is about fossil and renewable energy, both being part of the energy future in differing ways that need to be debated, discussed, and decided. It is about the new technologies that need to be invented to make not only delivery, but consumption and utilization of energy much more efficient. It's about electricity, about transportation, about heating. It's about low-cost distribution and distributed supply in the developing world and all that that will enable. So this afternoon, I hope we will have a rich discussion with 4 distinguished alumni panelists, and I'll ask them to please join me at the front of the room here, take their seats at the table in front of you. Our 4 panelists represent different decades from the Dartmouth and Thayer alumni community, the 70s, 80s, 90s, and aughts. So covering 4 decades of expertise and experience that they will bring to the discussion. So I'd like to just take a moment to introduce the panelists very briefly. You have detailed bios in the program in front of you. Speak for just a minute about the format of our discussion, and then we'll jump right into it. So at my immediate left is Christopher Gaut, member of the Dartmouth class of 1978. Cris is Chairman and Chief Executive Officer of Forum Energy Technologies, a publicly traded energy equipment and products manufacturing company based in Houston. And Cris is a former member of the Thayer School Board of Overseers. Next, we have Dana Guernsey, Dartmouth 06, Thayer 08, Director of Corporate Development at Ambri, a startup battery manufacturer based in Cambridge, Massachusetts, commercializing the liquid metal battery technology invented at MIT, something I hope we'll have some time to speak about in the discussion this afternoon. Dana's left, Andrew Lackner, Dartmouth 97, Thayer 98 and 99, who is a Senior Director of Investments at GE Ventures, leading investments in the power, water, and energy management markets. And so Andrew, of course, will bring a financial perspective to the energy challenge to our discussion. And last but certainly not least, at my far left, Marcy Reed, Dartmouth class of 1985, President of the utility National Grid in Massachusetts, a firm she joined more than 25 years ago, where she has held positions in finance, merger integration, investor relations, and corporate affairs. So welcome to our panelists. Now, in terms of our format this afternoon, we'll take about 20 to 25 minutes for moderated discussion. I have a series of questions that I will pose to the panelists. A few I will ask them to all answer. Most I will just ask for one or two short responses. These are both my own questions and questions that were generated by surveying our students, faculty, and staff in advance of this event. And then for the last 20 minutes or so, I'm going to open it up to questions from you and open discussion with the audience. And so I hope we'll have a lively and engaging exchange. Now, the first question I'd like to ask is actually immediately violating my own ground rules. I'm going to ask this of each of them, but it's a fairly general question I thought might be of interest, particularly to the students in our audience, and that is to kick off our discussion. Each of you, in different ways, made a decision, in some cases directly out of Dartmouth or Thayer, in others a little bit later in your career, to focus your work, focus your career on challenges in the energy sector. Take just a minute and tell us why, what it was in particular that attracted you, and why you've clearly found that to be an engaging and productive way to spend your time. So I'll start at my left. Cris, why don't you kick us off?
Yes, thanks, Joe. And I have been in the energy industry for my entire career. And what I found most attractive about that is that, first and foremost, it is an important area. It is important from an economic, a government standpoint. It's global. Huge technology, innovation, ongoing, and it's also capital intensive. It's big. It's big, it's important, and it's global.
All right, so to me, going into energy was about the combination of a lot of things I learned here at Thayer, including engineering, the merging of engineering and economics and entrepreneurship, and the huge potential for social impact and change. I think energy really is one of the forefront issues facing us today. And so to be able to be a part of that and have the engineering angle as well as the business context of how do we move this industry forward was just very, very interesting to me, coupled with all of the really exciting new things that are going on in energy that I'm sure we'll get the opportunity to talk about more later.
Great. Thanks, Dana. Andrew?
Yes, so before getting into energy about 7.5 years ago, I was working in venture capital. I worked in enterprise software, and also had worked at a strategy consulting firm, primarily working with IT and software companies. In the process of working in those industries, I was really missing the physical sciences. And one thing that's interesting and great about energy is that it encompasses so many different kinds of technologies and science that there's a lot of places where you can spend time, and it sort of continues to be interesting in terms of looking at new technologies and the diversity of the new technologies. But also, I really wanted to make a difference in the world, and I felt that where I was working in before, while it was focused on innovation, I didn't care as much about it as I do now in terms of working in the energy space, due to all the societal benefits that can be achieved through innovation in the energy space. So that's the real reason why I wanted to get back into energy.
And for me, the honest answer was it was an accident. After Dartmouth, I got my master's degree in accounting at Northeastern, and after coming out of public accounting, I went to work as an accountant at National Grid, then called something else. And so it was because I didn't like the job I had to take another job. And that's why I joined it. But why I stayed is probably more relevant, and that is that every day I feel like I and my team help to create the future and shape the future and what it looks like. And unlike some of my innovative entrepreneurial friends on the panel, I run the stodgy old utility, but I don't think that that's our role in the future, and that's what keeps me there.
Thank you. So, Marcy, I'm actually going to pivot off that, and I'd like to ask you that question. I wouldn't characterize a utility as a stodgy old utility, and of course that's not what you were saying, but that is in many ways the public perception. Slow to adapt new technology, regulated in many cases, utility, customers don't have choice, yet the technical challenges, the operational challenges you face are certainly profound, particularly for those of us who live in New England when we think about winters like the winter we've had this past year. And so comment on that for just a few minutes if you could. The operational challenges, but also talk about the importance that you see of technology innovation in a sector that most of us tend to think about as fairly static.
Yeah, sure, I will. So, the operational challenges are many. We are a large workforce, heavily unionized, lots of physical laborers. Those are the folks who actually keep the lights on and the gas flowing. And for honestly, I can say for many utilities across America, they get up in the morning and that is what their goal is: to keep the lights on and the gas flowing. And though we do that, I will say, what I said earlier, which is that we also take quite seriously our obligation to think about how the world needs to change and what the utilities' role is in that. And clearly, operationally, we will keep the grid running and put the lights back on when the wind blows and the trees fall down, or something else catastrophic happens to our network. But I think that we do honestly need to think about how we change along with everyone else. And as we may get into later, I actually view what will always be, I say always, you never say never, right? But what now is a fully regulated entity, how that plays, and can we be a playground for others who aren't? So can Ambri or Google or Nest or company not yet invented that someone in this crowd is going to invent, can they play on our grid? And therefore, we'd have to keep that the reliable, safe, responsible network that it is. So we play a role, and even the folks who have been there for years, and a lot of utility people do go to utilities and stay for years, think about their role in that space, and that's why the engineering crowd that we have working for us is really juiced up about their role in that equation.
Thank you. So, Cris, I'm going to turn to you because your work is largely in the oil and gas sector, and your career has largely been associated with companies in that space. Another industry I won't characterize as stodgy, but large, very capital intensive, and so public perception may be slow to respond, not technologically innovative. Fair or unfair characterization, I'm guessing it's the latter, and so why don't you tell us a bit about the importance of technology innovation in your world?
It's a tremendously innovative business in the oil and gas side of energy. And probably the most important example of that is the tremendous transformation we've had in energy resource availability in this country over the past 5 years, really, where we are now producing oil and gas from what were previously viewed as impermeable, non-porous resources. Although they contained hydrocarbons, there was no way to recover them. We found that we can do so. We can do so economically. In fact, we became so good at it that, as you pointed out, Joe, we took the gas price from $10 per MCF to $2.50, and more recently, when that one was overdone, we took the oil price from $100 to $50. So
many consumers thank you for that.
Yeah. We have figured out how to produce a lot of energy, and I think that is a tremendous benefit to our country, to our manufacturing industries, and that is a game changer.
So, Cris, just to follow on that a bit, that's an experience that many publications and economists have commented is largely confined to the U.S. We haven't seen that sort of activity overseas, and one of our faculty members had written in asking if you might be interested or willing to comment on that. What is it? Part of it, of course, is availability of supply. Is the shale gas, is the trapped shale or sand oil available in other geologic formations? But it's certainly not restricted to just North America. Why have we not seen this kind of a boom elsewhere? Is it regulatory technology? Is it people like Andrew need to be investing?
Yeah, in geologic sense, what we have changed from is that for the first 100 years in this industry, we produced from the reservoirs where the source rock, the hydrocarbons migrated from the source rock where the hydrocarbons were created to a reservoir where they were trapped and had good porosity and permeability. But just recently, we have figured out how to produce from that source rock and artificially add the porosity and permeability to produce. And these shale rocks, these source rocks, we know where they are. They're all over the world. What has caused it to happen first in North America is our approach to mineral rights, where there is an economic incentive for the landowner to allow access to those minerals. And that is not the case in many parts of the world. So if there's no economic incentive to have this equipment nearby, it probably won't happen. I think the other factors are already infrastructure, because it is very service intensive. We have a tremendous infrastructure that's been built up over a long period of time here, and we have an attractive fiscal regime. It will happen in other parts of the world, but we have to work through some of these other constraints. And in the case of oil, of course, the benefit is global because it is a global commodity, and as oil prices are driven down because of extra supply here, that affects, for better or worse, the entire world market.
So, Andrew, let me turn to you now. When you think about opportunities strategically in the energy space, do you tend to focus on opportunities that are fossil-related, or do you stay away from that generally and focus more in the renewable space? Give us a sense of what goes into your decision-making process on that front.
So, I guess within my team, there's basically people that are focused on the oil and gas markets and people that are focused on the power and energy management markets. So I'm personally focused on the power and energy management markets. GE has built up a large oil and gas equipment business recently. So we built that from basically $1 or $2 billion to over $20 billion through acquisitions over the last 10 years. And so we certainly believe in the prospects and the continued need for fossil fuels to fuel power generation and then also the transportation markets. Oil prices are a bit down, but oil prices will cycle with supply and demand, and so then you have to sort of expect that and ride those waves, through in the market. Personally, I've been looking at innovation in the power markets, and have been spending a lot of time looking at the disruption that's occurring at the edge of the grid and within on-site power. There's a large trend in the energy space is all of the innovation in terms of rooftop solar, energy storage, and the impact of on-site power on the grids, and the ways in which those two things can interact together in order to enable a more efficient distribution of electricity.
All right. Thank you. So actually, that's a very nice transition to Dana. The things that you worry about on a day-to-day basis touch very much on all the issues that Andrew just spoke to us about. The intermittency of renewable supply, the challenges of having on-site storage where there's local or distributed generation are very much the kinds of things that we think about from an energy perspective of being, systems challenges, storage challenges, and challenges that point very directly to demands on improvements in battery technology, which I know is certainly the focus of your current company. So why don't you tell us a bit about what it is that you're trying to develop and why storage is such an important component of the overall energy picture that we're discussing.
Mm-hmm. Sure. All right. So Ambri specifically, we're focused on large stationary storage for grid application. So what does that mean? I guess a couple things to highlight. First would be there's been a huge surge of renewable energy, solar, wind, and you start to get pockets. I'm just going to give an example. You start to get pockets where solar or wind penetration start to exceed certain levels that local grid can handle. And then a cloud comes by or the wind stops blowing, and now you have what we'll call intermittency problems. And how we currently deal with that today is that the gas peaking power plants or whatever other form of flexible capacity is on the grid ramps up or ramps down really quickly to accommodate. But very quickly, as you start to increase penetration of renewables, you get to a point where that's not really sustainable without one of two things happening in my mind, or three really. One, you can stop further renewable additions, which I would not advocate for. Two, you could invest in more flexible capacity in the form of fossil fuels. Or three, you could invest in energy storage to solve those problems. Those problems don't only occur in areas of high renewables. It's a really easy example to talk through. One other example would be heavy load pockets. So there are areas of Brooklyn and Queens and other congested urban areas where you can no longer get enough energy in to meet the energy demands in those load areas. And so there you can either upgrade your infrastructure, your transmission, your distribution, and that's really costly and capital intensive, or you can get creative with the grid edge. You can install battery storage, you can run demand response programs, you can look at energy efficiency measures, and so we're obviously focused on the energy storage side. And I believe that there's a lot of potential there to come and a lot of problems that can be solved. One other that I'll touch on is thinking outside of the United States and looking at areas of the world that are not yet electrified. A lot of the barriers there are that transmission is really costly, especially in remote rural areas. And so the idea that solar and storage technologies could get to a price point where you can then go out and install and electrify areas of the world that previously have never seen that is also very exciting.
So I have to ask you this related question. I'm sure you heard the announcement from Tesla yesterday. Tesla made...
What's Tesla?
Small West Coast company, soft-spoken CEO whose public notices occasionally attract attention. So I know since we were speaking earlier that, of course, you had the Tesla notice had caught your attention. In fact, you said your email inbox was lit up this morning with people asking you, did you hear about Tesla? Did you hear about Tesla? Did you hear about Tesla? So did you hear about Tesla?
Yes. Yes, I have heard. So if you are not in the energy industry all the time like I am, what Tesla announced today was what many of us already knew or pontificated on, is that they are entering the grid-scale energy storage market. They're developing something called the Powerwall, which is basically their grid bank of batteries, and they're going to pair up with their pals or cousins in Solar City. Elon is actually cousins with the CEO of Solar City, I believe, and offer grid-scale, both grid-scale and residential, which was news to me. I thought they were only focusing on residential energy storage for pretty low cost given where we're at today. And so my inbox was lit up. What does this mean for Ambri, et cetera? But I think what's more important is that this is a huge step forward for the energy storage industry. Previously, all of the conversations I've had, or many conversations I've had, have been convincing folks, be it friends and family, regulators, utilities, end-use customers, the government, about the merits of energy storage as a product. And now it seems that the conversation is starting to shift towards what type of energy storage. And I think there's space in the energy storage industry. I touched on only a couple applications in my earlier comment, but there are a variety of applications. There are different types of battery storage. There are different types of storage that aren't batteries. And depending on the application, you might want a Tesla battery, you might want an Ambri battery, you might want compressed air, or you might want other. And so it's exciting that we can start having the conversation about which on the menu of battery storage technologies do you want, and not just why is storage important. Right. So I like Elon, but, you know.
Thank you. So I knew you'd heard the announcement, so thank you. Right. So I actually want to step back from that to a more general question that I'm going to ask each of you, because something you said, Dana, is quite interesting in this regard. You know, I posed my question to you commenting on the renewable space and the need for storage technology, but you very quickly reminded me and all of us that it doesn't matter how the power is generated. There are tremendous mismatches between supply and demand where large-scale, grid-scale storage can make a tremendous difference. And so step back even further now. When we think about renewables, when we think about storage, when we think about energy supply and energy security broadly, globally, 10 years ago, as I said at the outset, when we thought about this, it was a geopolitical issue, it was an energy security issue, it was driven significantly by the high cost of fossil fuels. The world has almost completely changed since that time, in large part for the reasons that Cris articulated, but also because of a lot of the things that each of you are doing. So, is there an impetus to continue down a path of technological innovation right now? Is it climate change? Is it something else? Obviously, all of you are interested in having a positive financial return for your shareholders. But beyond that, what are the big drivers if it's not geopolitics and it's not global energy supply? So, Marcy, you're looking at me and nodding, so I'm going to point to you first, but I'd like each of you to touch on this.
I think we all would agree that there is something besides climate change for sure, I think, will help move this forward. And customer choice, from where I sit, utilities, as you mentioned earlier, customers don't actually get a choice. If you live in a town, that's your energy provider from your electricity company. But that's not how I experience our customers at all. They want to make choices around where they get their power from, whether it's on the grid or not on the grid, if they're going to have distributed generation on their property, how they are billed for their power, how they get to control their power. And so, even with prices of fossils depressed and the huge advance of renewables, which we very much welcome on our network, there are other reasons, which is just basic customer choice, that people want to, and that we should be moving forward with technology.
Right. Thank you. Dana?
Yeah, I'll also comment that I think the drop in oil prices of late, for me anyway, only highlights how volatile that market is, and that the idea that it might stay where it currently is crazy to me. And so you can have the conversation, all right, today's oil prices are low. Imagine if you could lock in those prices with sources of energy that will cost you that much forever, and protect yourself against future spikes. There's also the grid resiliency piece to speak to the retail variety of choice and customer choice. I know on a security side, the U.S. Department of Defense is very interested in how can we firm up our bases and how do we provide grid resiliency during huge storms to our urban centers and things like that.
Great, thanks. Andrew?
Yeah, so I think that there are really there's two sort of different types of innovation that are occurring, and really one is in developed nations and one is in developing nations. And so if you look at the sort of capacity requirements in developing nations over the next 10 years, the vast majority of new capacity additions will be in developing nations. And so there is still a hunger and a need for additional power and additional capacity to fulfill the demand, especially in the growing middle class in developing countries. And so then a lot of that is about the speed of being able to build out fast enough to meet the demand. In a lot of ways, it's hard to meet demand through a distributed energy resource approach. And so while countries like China and India are trying to ramp up as much as possible renewables, it's a lot easier to put in a really large power plant to fulfill demand than it is to put up 1,000 small power plants on people's roofs. And so then there is that sort of issue that's happening within developing countries. If you look at sort of what's driving some of the regulatory changes in China as an example, it's really microclimate issues. It's pollution issues in cities. And so that's not something you might have seen coming, but I didn't necessarily believe would drastically change their policy. But at this point, it's gotten so bad that now, because they're experiencing the issues with pollution, they have to change their policies because the public can't live in the cities anymore. And so then I think you're seeing some of those climate-related issues that are driving some of the policy changes in certain countries. Now, in the developed countries, there are it's more about empowerment and the adding flexibility and sort of the economic benefit of moving to your own power sources. And you're seeing that because of the decreases in cost from distributed generation technologies like solar, and you're going to continue to see that as solar and storage gets to be less expensive.
Right. Thanks. Cris?
Right. So I think there are three important trends that we ought to keep an eye on. One is that on a global scale, the demand for energy is growing, will continue to grow just because of the developing countries that we were just talking about and the needs that continue to be there. The second is climate change and the desire for cleaner sources of energy. But yet the third is that the largest producer of energy in the world is still in the Middle East, primarily Saudi Arabia, but the other countries there. And they are of the view now that they want to keep the economics such that they're in business for the next 100 years, that they don't want the cost of energy to get so high that people don't need the only thing they can produce. They want to keep doing that. They need to keep doing that. That's all it got. So they seem to have made the decision here that they want to keep energy prices a bit lower than they have been. And I think those three important trends are ones we shouldn't lose sight of.
Thanks. So I'm going to ask one last question. I'm going to direct this specifically to you, Cris and Marcy, before I open it to the general audience and discussion. It isn't an area where either of you have particular expertise, but some of the things you've commented on have touched on this in a general way. Is there a future for coal? All right, we can open it to the general audience now.
Yeah. So I think coal is in our future. We have successfully almost fully removed it from our plants, the plants in New England. But, politically, let's just face the facts. In America, coal is a source of income for a number of our states. The existence of coal and the economics that it drives is, I think, one of the main reasons why we don't have federal energy policy. So my hope is that we find a way to really utilize clean coal in a way that it is actually clean, and to find a place for it in the mix. If we didn't have it, we'd totally survive because there's enough other technology to get us through the day.
But maybe again, thinking globally, looking at any projection, any survey of sources of energy, it is so hard in the near term, it's impossible in the near term to come up with a scenario where we can meet the world's energy needs without coal for a period of time. So it will be with us for a period of time. We need all the sources of energy that we have, and then some as the demand grows. So it'll be with us for a while, I think.
Thank you. All right, I'd like to open it up for general discussion from the audience. I see a few hands. So, Christopher, you first, then you, Christine, and then I will raise my gaze to the back of the room. So go ahead.
I'm Chris O'Brien. I was a player from Dartmouth 79 there. I've worked in the solar industry for the last 20 years or so. But the question I had was, so there's a lot of parallels between the transformation that occurred to the infrastructure of the telecommunications industry and the transformation that's underway in the electric utility infrastructure. I guess in the telecoms industry, there's almost no remaining vestige of the infrastructure that existed a generation ago. To date, in the electric industry, we've had sort of a hybrid approach across different states and so forth, but there seems to be this, the assumption is that the grid, as we know it, will remain, it'll evolve, it'll become smarter, and so forth, but the fundamental grid will remain the same. And I guess my question is, if you go ahead 10 years, do you think that will there be the same sort of disruption to the electric grid as occurred in the telecom industry?
Marcy, we're all looking at you.
Well, I certainly hope so. Really, I mean, there are lots of utilities in the world. Certainly, just look at America for a moment. But there are lots of utilities who sure hope that doesn't happen. Their business model is based on generating, transmitting, distributing, and billing you for energy. And but that's just not the reality in which we live. And so, there are plenty of examples where we've got grid modernization happening, smart grid pilots happening, where you could envision a customer disconnecting from the grid. I don't think that's going to happen en masse anytime soon, for all the reasons that we've been stating up here. But we have to be open to that thought, truly. And I think that the utilities, the regulated utilities, such as the one that I run, who think that by stomping hard and saying all the reasons why that would be really bad, I just think that they'll go by the wayside, because it's just not going to be the way it's going to be 10, 20, 50 years from now.
And I should ask, so thank you, Cris, for identifying yourself. When I call on you, please identify yourself. And if you're directing your question to a specific member or members of the panel, please do so. Christine, you had a question?
Christine Buckman, the math major at Dartmouth, John Kennedy, the 3 Mile Island Commission. So I wanted to expand on the question about coal. What about nuclear? I thought I was dead around here, and now we're scoffing and run about their ability to have it. What's going on globally with power production from that source?
That's a jump ball. Anyone can choose to answer that.
I mean, I am not a nuclear expert at all, but to me it seems like a political question. And, I defer to others on the panel here, but nuclear is a clean source of energy. There's a lot of concerns about it, especially after Japan. And so it seems to bring us into the world of politics, which energy inevitably always gets into the world of politics as a barrier. But Andrew, did you want to?
Yeah, so I think that the catastrophe in Japan has really made people really pull back from even their existing nuclear plants. GE has a nuclear business, but I don't think we've sold a new plant in something like 15 years or something. There is more innovation happening. I mean, we see micro nuclear plants and different approaches to nuclear energy that could be potentially very promising. But the development cycle in those technologies they've been in process for 15 or 20 years, and they might be another 15 or 20 years before they really come out to a point where they can be commercialized. So I think that right now that there's the issue with sort of getting a permit for a new nuclear plant is really part of the major issue, and also the capital intensity of building a nuclear plant relative to other options. It makes it sort of a hard thing to do, certainly in the U.S. today.
Yeah, in the middle here.
I'm a Hanover resident. My name is Marcy. I'm on the local town committee, which is called Sustainable Hanover Energy Committee. And I just want to mention that over the last winter months, the town brought forth an action for Hanover residents and small business to get in a group buy solar panels, and over 60 homes opted to do that. The third phase of one of their options will be to offer, you mentioned options for people to buy renewable energy. Most of Hanover is covered by Liberty Utilities, and they don't really have that option. So the town will, again, have a group buy where people, residents and possibly small business, can opt for renewable/green energy at a set price for a set number of months. There'll be a special presentation on that on May 14th. My question is, the New Hampshire Department of Office of Energy and Planning, one of their energy goals is to encourage distributed generation, small scale, mostly renewable energy, probably solar, but also maybe hydro. And can you address the challenges and the opportunities and advantages of having more small scale generation in a large grid?
Is that to me? Yeah, okay. First of all, National Grid used to serve the Hanover when we had before we sold the New Hampshire business to Liberty, and I desperately miss that we served Hanover, and I used to come up and visit. But I'm happy that New Hampshire is doing that. If you just look at Massachusetts for a moment, where just pick solar. So now former Governor Patrick asked for 1,600 megawatts of solar to be built and connected in Massachusetts by 2020. We'll far exceed that goal. We'll get there way before 2020. And it's largely to rooftop here, rooftop there. There is some utility scale, but mostly it's small stuff. And what you need is an active market, which does exist. It will come to the state if it's economically attractive for them to do so. And then you need the utility company to make the connection. But at that point, it's a tell to the utility company. They'll be told to do it. If they choose not to want to do it willingly, the regulation will require them to do it, or the legislation. So it can happen. I mean, you just look across the border to what is happening down in Massachusetts, and it's thriving. Massachusetts was named, I think, number 5 in the country in states on solar per capita. And it isn't because we're a real sunny place, but rather because the economics that we drove through legislation and regulation. So it can happen.
Thank you. I think there was a question back in the, yeah.
Hi, thank you so much for speaking. My name is Tyler Bishop. I'm a 14 and current PhD student head there. I haven't really been keeping up with what's been going on in the energy world, so this may be a stupid question, but what's the word on the street about fusion energy?
So Andrew and Dana, why don't you tackle that one? Fusion energy.
Apparently I haven't been keeping up either. I don't know on that one. Do you?
Yeah, so There are some experiments that are taking place that are, are showing some results that people can't really explain. Really, I mean, it's well, in the fact that there could be potential for low energy nuclear reactions in the future, and there's sort of you're at the edge of people's ability to understand the science and physics, meaning that there are some results from experiments, and people are trying to understand if the experiments are real. But for right now, it's still early in development, but there's some interesting work that's being done, and there's some things that are going on that people are trying to understand better. But it's probably going to be a while before you can have a new type of reactor that would be able to power a power plant, as an example. And it could be forever. It could be 10 to 20 years. But right now, it's hard to say.
Okay, so Mr. Ballard and then Mr. Sandell. So John?
I'm a little bit out of date with this question. My question goes to the cost per kilowatt hour that's now available on a 24-hour basis with alternative energy. I was looking at Hanlon maybe a year ago, and they were shooting for 7 cents a kilowatt hour or something like that. And they missed it by roughly a factor of 2. And they said, we'll get there, and I quit looking. And I saw some other work that was proposing sort of novel storage techniques, compressed air and so forth, with alternate wind or solar. And they weren't going to get there either. And my take was that parts of the government funding research were really looking for a solution that provided storage and power and was reliable, and about 7 cents a kilowatt hour. And it didn't seem they were getting there a year ago. Any better off now, or am I missing the boat? What's going on?
So anyone comment on the cost of renewables and the goals?
Yep. So the cost of first I'll talk about solar. So on a utility scale solar basis, I do think we're there with the 7 cents. We're as low, I'm not quite sure how it works, but we're as low as 4 or 5 cents in some of the recent deals. But in 2014, on average, I believe it was around the 8 cent mark for solar utility scale kilowatt hours. When it comes to storage, it's a little bit harder to talk about it on a per kilowatt hour basis on a cent, just because storage it's not creating the energy. So you have to look at the whole system. And so I think right now I've seen systems, solar plus storage, that get down there. I don't know that we're quite at 7 cents yet, but I also think that the storage industry is just at the cusp of really dropping their costs, similar to where solar was in 2004, 5, 6. And so I do believe that we will get there. I think solar is there. It might take a slight step back with some of the tax incentives going away shortly, but those costs will continue to come down, and I think in a few years we'll be able to say that, yes, solar plus storage systems can get you energy at that price.
Scott, you had a question?
I wanted to come back to your question about fusion energy. We have a portfolio company, I'm in the class of 86. We have a portfolio company called Tri-Alpha Energy, which I'm sure Andrew's not familiar with, because there are something like a dozen Nobel Prize winners who've been working for decades with this company in Southern California, which has something way more than an experimental system, which works and is theoretically at the point where the physicists can't understand why it won't work at a commercial scale. They expect to go into production in about 2018. So it's not too far away. It's extremely economical. It uses an element of the Earth's surface, which is widely abundant. Tri-Alpha Energy.
All right. Question here in the middle.
I'd like to talk to you later.
It's for sale.
Andrew took notes.
Yeah.
I'm Duncan Wood. I'm Player 71. I have 2 questions. I don't know who wants to pick up. One is probably Marcy. The role of conservation. I know the utility companies for the last, 5 or 10 years have been pushing various programs, be it light bulbs or better pumps, better motors, whatever, to try and reduce demand. And I don't know how those incentives, many times you read that much more power is used in buildings than in automobiles. And so we worry about miles per gallon, but yet we need to tighten up our buildings or change our building codes and whatever. So I'm intrigued whether she feels that's helpful. And then the second one, in the storage world, I keep wondering whether hydro pump storage, what we have at Bear Mountain and
Bear Swamp,
Massachusetts, what we have in Niagara Falls on both sides of the river, whether that could be tied to wind power or something, so you can pump the water when you have the energy and drop the water when you need it. I'm just wondering if people, I know that flooding forests may not be a popular thing, but I keep thinking that it's a technology that's well proven.
Right. So let me ask the panelists for quick answers. I'm going to take a few more questions because I am conscious of the time. So Dana and Marcy, I think they were directed to you.
All right, I'll answer the storage piece. I think pumped hydro is absolutely a great resource for doing exactly that, smoothing out the intermittent resources. And the challenge with pumped hydro is just that there aren't that many places in the world where you can do it. There's just the land and siting requirements. But I do think it's a wonderful technology and something we should do more of.
And yes, building codes need to catch up with reality. And as part of the Global Warming Solution Act in Massachusetts, we actually try to address building codes because there's a lot of good work that's done in energy efficiency, but it's not embedded yet within the building code space or realtor space.
Thank you. So, question over here.
Carolyn, I'm a PhD student here, second year at Thayer. My question is, normally we would come to any members and say, hey, if we have this set of skills that we want to solve your problems with, but instead, why don't I ask, what problems do you guys face on a daily basis that we Thayer students can help solve? Because we don't have as much chance to learn that. So I can ask all four or one or two.
Oh, let's go down the line quickly. Cris, you first. Make sure your answer, each panelist, please, includes an ample selection of Thayer courses and lab work.
One of the things that we manufacture within my company are robots that operate in the deep water around the world, and robotics is an area that we need engineering talent on a continuous basis.
I think you can take any engineering discipline and find a place in the energy world where it could have a home. There's chemical engineering, software, mechanical. What I wish we had more of were those engineers that then also understood a little bit more about the energy markets and how it fits into the financial and the business context.
Andrew?
Yeah, and I'll echo that same sentiment, but also expand it to say that in terms of like control theory and systems development and the ability to develop controls for distributed assets and the ability to optimize for different types of things, that type of software is going to become much more important. And generally speaking, and the grid is going to be enabled with many more sensors, and so the flood of data that's going to be coming from the grid overall, and the interpretation of that data to optimize for particular solutions or to solve particular problems is going to be an area of I think where there'll be a lot of innovation in the coming decade.
And I was going to say exactly that, and how you apply that with artificial intelligence. It's the big new world.
All right, so I will take two more focused questions. There are many hands, but I'll take one from the front, one from the back. You're making it painful for me. So, Barry, you've been waiting patiently. Sorry, Will. And then Travis will give you the last question.
I'm concerned about American competitiveness. We're a manufacturing company with locations all over the world in this country. And our cost of energy in Germany is 3 times the cost of the United States in manufacturing. Germany has shut down nuclear power plants. And they're still using coal. They're not fracking for gas. They're using windmills. They're very proud of the windmills and the solar work they're doing. So what I'm concerned about is if we move to a culture, i.e. much more of these renewable energy fuels, what might I expect is our competitive nature in this country? And I think we have an advantage in the world now. Are we going to throw away the advantage of natural gas or some of our other means? Unwisely, in my view, quickly to other renewable energy fuels.
So I'll let two of you answer. How about Marcy and Cris? Why don't you tackle that?
So Germany's problem wasn't because they went to renewables too fast. It's the economics they built around it, and the feed-in tariffs just didn't work. And so the good news is the rest of the world is learning from that. Yeah. Short answer.
Barry, I feel your pain. As a manufacturing company, we manufacture in Germany, and it is one of the highest cost areas that we have, certainly from a power standpoint, and many other areas. On the other hand, those remotely operated vehicles we use to put in the wind farms offshore Germany. So I'm kind of torn on that one. But the ability now to produce so much gas, I think, is a sustainable advantage for the U.S. and certainly for U.S. manufacturing, and it helps our competitiveness.
So we'll give the last question, Travis. I think you had your hand up. We'll give the last question to a student.
I'm Travis. I'm a master's student. So I have a question around intermittency and renewables. So basically, I think a lot of that has to do with redundancy in the grid. So I guess this question is for Marcy. So do you see that relaxing regulations around the level of redundancy that's needed, and perhaps having users pay for the amount of reliability they need could be a solution in addition to storage and the other solutions that would go along with that?
Maybe. Yes, for big players, but if you think about the general public and the residential base, in particular, customers of ours who can't afford to take some of the options that we have, or low-income customers, I think that the grid will always need to have some level of redundancy built into it. So I say maybe. If you're a large manufacturer, and we talk to Raytheon on a daily basis about their grid, we can do a lot of different things for them that we can't do for someone living in a triple-decker in Worcester.
So I lied. I'm actually going to take the last question. I'm going to take podium prerogative, but this is an easy question, a softball question, but relevant to those of us who work here at the Thayer School of Engineering. I'm going to ask each of you. Marcy, we'll start with you, go down the line, so Cris, you get the last word. If you were to advise us to create one single course that would give students access to some of the big, or an understanding of the big challenges they would face in the energy sector and would help prepare them to come to work in your organization, what would that be? And remember, it's an engineering school, so technical content is okay.
I would build some sort of course around technology and consumerism, to get at that question that Travis just asked around how can you help us with some of these big societal questions that we're honestly grappling with. And it's not really so much the technical answer, but maybe sort of some of the psychological and societal answers that we're looking for.
Thank you. Andrew?
Yeah, so I think that as an potential elective, the understanding of the market dynamics in the energy industry and the impact of how things work in the regulatory environment is very important to understand in terms of understanding how the overall market functions and how to potentially look at how to changing the market. So that would be, but less on the technical side. So that's why I've made it an elective, not an
I'll come teach that.
Well, since Andrew took my answer, I guess, so one area that is exciting is what we're calling the Internet of Things, and so some sort of a systems level class where I feel we do have all the pieces of the puzzle right now from a technology point of view, and the challenge, we have many pieces of the puzzle, and I argue enough. And the challenge is, how do you integrate it? How do you get them to talk to each other? How do you get the software layer and the applications there and the right algorithms? And so after you've taken Andrew's class and you understand the energy markets, how then do you take a systems approach to how all of these different technologies can interact with each other and optimize from there?
Cris?
Yeah, I think as a later level course, bringing together Thayer's strength in the focus on energy and on entrepreneurship, it is a tremendously innovative industry. I think there are great opportunities for entrepreneurs who have developed new products to develop those markets across this broad industry, and I think that would be a great way to culminate the experience here. Thanks.
Thank you. Well, other than my surprise that none of you recommended an advanced graduate level course in condensed phase energy thermodynamics, thank you for your answers. Thank you for the discussion.